Good morning, ladies and gentlemen, and welcome to Mrs. McKinney's class. Oh, yeah. So, here what we're going to do is we're going to figure out how to use the quadratic formula. Remember that we are using the quadratic formula in order to find the x-intercepts, which are also called our solutions, which are also called our roots, oh yeah, and they're also called our zeros. So there's a few things we're going to point out before I get started. First things first, our equation, although it looks, very challenging, there are some things that we know from before. Number one, our axis of symmetry. We use the formula x equals the opposite of b divided by 2 times a, and that gives us the axis of symmetry, which is that invisible line that splits our parabola in half. Next, we have our discriminant, which is in our notes, and our discriminant is b squared minus 4 times a times c. Notice how I'm saying it, b squared minus 4 times a times c. And the discriminant is found inside of the radical of our quadratic formula, and the opposite of b divided by 2 times a is outside of that radical, so it's also a part of our quadratic formula. It all kind of fits together as we work. So we're going to take this one piece at a time to help us to kind of break this down. So let's look at our first example. Our first example is here, and what I have there is 4x to the second power minus 7x plus 1, and then that equals to negative 2. Now, with that being said, what I want to do is I want to make this equal to 0. Well, before I do that, there was another example. Yeah, there was that example. Okay, so let's start with this example. I know. I should have did it beforehand. Forgive me. You know I make mistakes. It happens. So here I have my first example, and this one's already set equal to 0. So we'll do that next, the other problem I just had a second ago after this one. And so what we're going to do is start by breaking down this problem. The first thing we do is identify A, B, and C. So I'm going to begin by writing down this problem on my paper. Hopefully you already have it, which will help you save a little time. That's why I write in pencil, because we make mistakes. Accidents happen. And even at home, nobody's perfect. Okay, so here I have my equation. We start by identifying A, B, and C. And I like to put that off to the side. You guys know that. So I have A, B, and C. A, B, and C. So my A value is going to be 1. My B value is going to be a positive 8. We're going to respect our signs. And C is a negative 20. A is always found with our x squared term. B is always our x term. And C is always our constant. So now we're going to go into finding our discriminant. Now, when we use our discriminant, what you read from your notes said that the discriminant is going to tell me whether I have one solution, whether I have 2 solutions, or whether I have 0 solutions. And when you looked at the graphs, you would see examples of each one of those that we had in our notes. So from here, what we're going to do is we're going to start by finding how many solutions am I going to look for by using the discriminant. So whenever I use a formula, I always start by writing the formula so I can substitute directly into where it is, and there's little confusion about what went where or why I put something there. So here I have b to the second. My b value is 8, so 8 to the second power. Then I have minus 4 times a, and my a value over here was 1. My c value, negative 20. And we're going to solve for that first. So we have 8 to the second power, 64. I have negative 4. Yes, that says minus, but a minus in front of a number just means that is the negative of that number. So this is negative 4 times 1, negative 4. And negative 4 times a negative 20 gives me a positive, because the negative times the negative is positive. Watch your signs. And that gives me 80. So now what we're going to do is add those two things together, and it gives me a 144. Now we look back at our notes, because I know you have them. And what it said for our discriminant is, if our value is positive, that means that there is a solution. If my value is a positive perfect square, this is a perfect square. then I'm going to have two real number solutions. Not just real numbers, but whole numbers. And if I have a positive number that is not a perfect square, then I'm still going to have a real number, but that means I can wind up with a fraction or a decimal as my answer. Don't stress. I'll show you an example of that as well, especially if you join me later for our live call. So here I have my perfect square. So what I'm going to do is take this value, and now I get to place it into my quadratic equation. That sounds really complicated. I pinky promise it's not. So here I have x equals, what do we need on there? I have x equals, the opposite of b, we did this before, the opposite of b would be negative 8. We're going to plus or minus it and do the square root of everything that I have up here. We just saw for it was 144. So I could just get to write 144 in here to save myself a little time, heartache, and sadness. And then we have in 2 times, our a value was 1, and 2 times 1. Now we simplify. See how easy this looks now that we kind of broken things down in steps. So I have negative 8 plus or minus the square root of 144 is 12, and then divided by 2. Now what I'm going to do is split my problem into 2 different things. What am I talking about? See how I have a plus and a minus there? Yeah, it's plus minus. We're going to split that and do one problem that has plus and one problem that has minus. So over here and then over there. So I have negative 8 plus 12 divided by 2, and then negative 8 minus 12 divided by 2, because I have to take both of those 2 different values. Again, we're supposed to wind up with 2 solutions because this was a perfect square. So this is going to be the value of my 2 solutions. So negative 8 plus 12 gives me a positive 4 divided by 2, which equals 2. So the x value for one of my solutions is going to be a positive 2. We will write that as an ordered pair as 2, 0, because my y value is 0 at the x-intercept. Now over here, I have negative 8 minus 12. That's going to give me, you're so smart, a negative 20. And we divide that by 2, which gives us a negative 10. So my ordered pair for the x-intercept is going to be negative 10, 0. Again, all of this plays back into what we do in order to write our parabola. Remember, my parabola goes like this. And doing a quick sketch, this is not going to be like, technical. If I use the same thing I had up here, meaning my axis of symmetry, we use the opposite of b divided by 2 times a. We did that a second ago over here. The opposite of b was 8 divided by 2. That gave me a negative 4. So my axis of symmetry, I'll put it over here to the side, is equal to negative 8 divided by 2, which gives me negative 4. So that means I have an invisible line, 2, 4, 6, 8, 10. I'm only doing it that way so I don't have to draw a really big graph. Is at negative 4. Negative 4. So I'm going to draw a visible line down here at negative 4. It's telling me that my 2 x-intercepts are at positive 2 and negative 10. So at positive 2, the graph is going to come, over here, positive 2. That was 4. And negative 2, negative 4, negative 6, negative 8, negative 10. I have another point that goes here. Because my graph has a positive a value, that means my graph is going to open up. So these are going to go down like this. And now I just have to figure out my vertex. We plug our value from our axis of symmetry back into the original equation, and that will tell me my vertex. So negative 4 to the second power and no, you don't have to do all of this right now. I just want to show you how everything kind of comes together to make this problem make sense. And so I have negative 4 to the second power, which gives me 16. I have 8 times negative 4, which gives me a negative 32, and then minus 20. This is going to give me a negative 16 minus 20, which gives me a negative 36. So my vertex is going to be somewhere way down here. I'm just going to put the point there because I'm not drawing all the way down to 36. And we make our U that goes up and around like this. Remember, even points about our axis of symmetry. It all must flow and go together. Okay, that's it for my example.